Let's now look at the assembly language program to sort an array. What is the first step? The first step is to initialize the count registers. In this program, we need two count registers. One to keep track of the number of iterations and another to keep track of the number of comparisons in an iteration. In the question, it is given that the number of elements in the array is stored at memory location 4200H. So we can get n from that location. We can subtract 1 from that value and you will get the number of iterations to be performed. And the number of comparisons to be performed in the first iteration is also equal to n minus 1. So the first step is to load the data pointer with the value 4200H. So we give the instruction move dptr comma hash 4200H. After executing this instruction, dptr will contain 4200. Then we need to use the movex instruction to get that value into the accumulator. Movex a comma at dptr. After executing this instruction, accumulator will contain n, which is the number of elements in the array. The count we require is n minus 1. So we have to decrement the accumulator. DECA will decrement the accumulator. The accumulator now contains n minus 1. Which is the number of iterations to be performed and the number of comparisons to be performed in the first iteration. Now we need to store these values into two registers. Let R0 be the register that keeps track of iterations and R1 be the register that keeps track of comparisons. So first we will copy this value n minus 1 into R0, move R0 comma A. Then we have to copy the content of R0 into R1 also. For that you cannot do it directly. There is no instruction to copy R0 into R1 directly. So first you have to copy R0 into the accumulator, then copy accumulator into R1. So after this instruction, now both R0 and R1 contains the value n minus 1. Now we have initialized the count registers. Now we can initialize the data pointer to point to the start of our data. Now our data is stored at memory location starting at 4000H. So we have to load data pointer with that value, move dptr comma hash 4000H. Then you can get that value using the movex instruction, movex a comma h dptr. The first element of the array will now be available in the accumulator. Now what should we do? We have got the first element. We need two elements for comparison. So we need to get the second element also. So when you have to get values from the external RAM, you have to use the accumulator. So if you get the next element, it will also come into the accumulator. So first we have to store this number into another register and then get the next element. And before doing that, we should decide how are we going to compare these two elements. The instruction that is available in 8051 to compare values is CJNE, and we already know that the most common use of CJNE is in the form of CJNE A comma B comma relative address. We are going to use that form here also. So we can store the first element into the B register and get the second element. So let's copy the content of the accumulator into B register. Now the first element is in B. Now we have to get the next element. To get the next element, we have to increment the data pointer. Now it points to the second element. Using movex, you can get that value. Movex a comma h dptr will copy the second value into the accumulator. Now at this point, we have one value in accumulator and the other in B register. So now you can use the CJNE instruction. CJNE A comma B comma L1. Now let's decide where should L1 be. In our particular program, it is not important whether the numbers are equal or not. We need to find which is larger, which is smaller. So we have to check the carry flag. So that is the important step. So L1 will be given as the label of the next instruction. And we are going to use the JNC instruction to check whether the carry is set or not set and decide on the following steps to be taken. So whether A and B are equal or not, we will come to L1. So what does CJNE do? If A and B are equal, it will execute the instruction immediately following CJNE. If they are unequal, it will jump to L1. Now we have given L1 as the label of the next instruction. So if A and B are equal, we will go to L1. If A and B are not equal also, we will come to L1. And there we are checking for the carry flag. Now we are using the JNC instruction, and now let's see why we should use the JNC instruction. So now the first element of the array is in B register and the second element of the array is in the accumulator. Now if there is no carry, what does it mean? If there is no carry, it means the second element, that is the element in the accumulator, is the larger one. Among the two, the second element, that is this element in the accumulator, is the larger one. That is, if carry is not set, then if there is no carry, the elements are already in the ascending order. The second element is in A, the first element is in B. A is larger, which means the second element is larger, which means the elements are already in ascending order. So if there is no carry, it means elements are in ascending order. We need not exchange them. So if there is no carry, we will jump to L2. That is, we need not exchange. We'll decide what is to be written at L2. And suppose there is carry. What should be done? If there is carry, it means the numbers are not in ascending order. Accumulator is smaller, that is second element is smaller than the first element. So they have to be exchanged. And how will we exchange? We have the second number in the accumulator. Now we have the second number in the accumulator. It has to be stored to the first position. So what should we do? We should decrement the data pointer. There is no instruction to decrement data pointer, so we will decrement DPL instead. The data pointer contains two registers, DPH and DPL. DPL is the lower byte of the data pointer. We will decrement the DPL register so that the data pointer now points to the first memory location. And we will store the contents of the accumulator into that location. That is, what are we going to do? We will store the second element into the first position. So that is the first step of the exchange. We will decrement data pointer. Since there is no instruction to do that, we will decrement DPL. Now data pointer points to the first memory location. And the second element, which is smaller, it has to be stored into that location. How will we do it? We will use the MOVEX instruction. MOVEX at DPTR, A. Now the second element will be stored at the first memory location. This is the first part of the exchange operation. Now after that, what should we do? We should store the content of the B register into the second memory location. So to do that, we should copy it into the, that is, we should copy the content of the B register into the accumulator. Only then can you store it into the external memory. You have to go through the accumulator to store anything into external memory. So now the larger value is in B, it has to be copied into the accumulator and then stored into the second memory location. So first we will store B register into A. Now the larger value is stored in A. Now we have to store that into the second memory location. The data pointer now contains the first memory location. So you have to increment the data pointer so that it points to the second memory location. Now you can store the accumulator into the second memory location using MOVEX instruction. So when you execute the MOVEX instruction, the larger element will be stored into the second memory location. So I hope it is clear now. Since this is a video, you can listen to it as many times as you need. If you still don't understand, you can call me. So now we have finished the exchange operation. Now we can move on to the next comparison. Before that, we should check whether the counts have become 0, whether the number of comparisons has reached 0 and whether the number of iterations has reached 0. So now we have only completed one comparison. At this point, that is when we reach L2, we have completed one comparison. And so we should decrement the count register for comparison by 1 and check whether it is equal to 0. Which is the count register that stores the number of comparisons? It is R1. So we must decrement R1 and check whether it is 0. DJNZ R1, L3. Now there is another thing that we should note at this point, that is at L2. When you reach L2, the accumulator contains the larger value. Whichever path you take, whether you come directly to L2 or you do the exchange operation and come to L2, the accumulator now contains the larger among the two. It should be stored into the B register. We are following the logic such that the B register contains the larger among the two, and we will compare a new element with B register. So from L2, when you go to the next comparison, you have to store accumulator into B register. Then what should you do? You should get the next value and compare it with B register and so on. So where should L3 be? L3 should be the label of this instruction, move B, A, because now accumulator contains the larger value and you have to store it into the B register. And from there you have to take the next element, increment DPTR, then MOVEX, then compare and so on. So L3 should be the label of move B, A. Now after the first comparison, we have now reached, we checked R1. If it is not 0, we will come to L3. Now when we reach L3 and after executing move B, A, now B register contains the larger one among the two numbers that were compared. Now you have to compare the next element of the array with this larger number. So for that, increment DPTR, move it say DPTR, get the next number into the accumulator, compare both. Compare the larger one with the new number. The new number is in the accumulator, the larger one is in B. And again, the same logic applies. Check for the carry flag. If there is no carry, then it means you have to, you already have the larger element in the second position. And if there is carry, it means you have the smaller element in the second position. You have to exchange and continue in that fashion Again, decrement R1 and see if the number of comparisons is over. And during the first iteration, after R1 becomes 0, what does that mean? When R1 becomes 0, it means that during the first iteration, when R1 becomes 0, the largest element will be at the bottommost position. Now, after first iteration, what should you do? After one entire iteration, you have to check whether R0 is 0. You have to decrement the number of iterations, that is, you have to decrement R0 and check whether it is 0. If it is not 0, you have to continue with the next iteration. So to do that, you should give the djnz instruction with R0 as the first operand. And if it is non-zero, you go to L4. So if the number of iterations, if the required number of iterations has not been performed, we will go to L4. Where should we place the label L4? Now what does R0 contain? R0, after first iteration, R0 will contain n minus 2. R0 initially started off with the value n minus 1. When you execute this instruction, it has been decremented by 1, which means it now contains n minus 2. That value is the number of comparisons that has to be performed in the second iteration. And which register should hold that number? R1 should hold that number. R1 should contain the number of comparisons. So we can copy the content of R0 into R1 so that it will contain n minus 2 in the second iteration. So where should L4 be? L4 should be the step where we copy R0 into R1. So R0 is copied into accumulator, then accumulator is copied into R1. Now R1 will contain the number of comparisons to be performed. If this is the second iteration, it will contain n minus 2. And we have to start from the first memory location onwards, because which location should we avoid? We are avoiding the last location because it already contains the largest element. But the top of the array, it is not in sorted form. Please refer to the logic video. You can see that the bottommost element has occupied the correct position, but the topmost elements need to be compared again. So we should start from the first address onwards. So we have copied the data pointer. We have copied the value 4000h into the data pointer. That is the first address into the data pointer. We got the first element into the accumulator, kept it in B register, got the next element into accumulator, compared, and if there is no carry, it means they are already in ascending order. If there is carry, it means you have to exchange them. And again, check whether the number of comparisons is complete. If not, go to L3, that is get the that is store the larger number into B register and get the next element and compare, and so on. When the content of R1 becomes 0, the second iteration is over. And we proceed in this fashion until all required iterations have been performed. That is until R0 becomes 0. When R0 becomes 0, our array will be in sorted form. So let us look what happens during each iteration. See, we start off with this value. Our initial array is, consider this example, 2, 4, 5, 3, 1. And we start with the value of R0 equal to 4. Because R0 contains n minus 1, n is equal to 5, R0 is equal to 4. After the first iteration, that is when we first reach the djnz R0, L4 instruction, R0 will contain 3. It has been decremented once, and the array will be in this form. That is, the largest in the array will occupy the last position. The remaining elements are unsorted. Then after the second iteration, R0 will be decremented again. It will contain the value 2. Now, two elements 4 and 5 have occupied their actual positions, their correct positions in the sorted order, that is they are in ascending order. The remaining three elements remain to be sorted. In the next iteration, the content of R0 becomes 1 and three elements have been sorted, 3, 4, 5. They are in ascending order. And now two elements remain to be sorted. So we have only one comparison left. R0 is equal to 1. R0 at this point, when we execute this instruction, R0 will contain the number of comparisons to be performed. So now in this iteration, you have to perform only one comparison. And in that iteration, the last iteration, when you reach this point, that is when you reach the djnz instruction, the content of R0 becomes 0 and the array will be in this form 1, 2, 3, 4, 5. The array has been sorted. And we end the program with the never-ending loop L5 is jump L5 because all microcontroller programs have to run continuously once the device is switched on. This is going to be the most complicated program in our course, I think, because I feel that all other programs are easier than this. Please listen to this many times, take a paper and pen and try to work out the contents of registers and the array and try to understand this program and learn. Please don't try to by heart it. It's not worth by hearting this program. Uh, Use this program to develop your programming skills. Thank you.